Welcome, guys, to my little lecture and a handover for Future Landing. I'm quickly going to go through and introduce the project that I did for Future Landing. The link, I've dropped the link in the chat box so you guys can have access to it. The idea for the project sort of came about, while me and Virangana were talking about, obviously, it happened during the first wave of COVID. So we were all stuck gazing through, different kind of windows and screens. So the idea of, what is a site, what is virtual, was something that we were pondering about. The idea of shifting through screens is also something that was. We also spoke about tactility, about touch, and about breath, and about how our environments affect us. I think that's something that we always having a conversation about, because she is very interested in the idea of tactility, the idea of using your hands, and I am someone who works primarily with my hands and sensory overlap. So the idea of touch, of your immediate environments and cross-modal sensory perceptions was always something that was on the discussion board between us. We also came across this, I think I was introduced to it by Virangana, actually, like a little write-up, a little book by Tina Camp, which was called Listening to Images, where she speaks about sound as embodied process, where we register multiple levels of our human senses, and uh, basically how sound cannot just be heard, it can be perceived. It is in an equally powerful way that it can be felt, it can be touched, and it has a faculty to move people. So taking from this idea, we sort of came up about with this idea of having sound and environment blend in together via screens. We were talking about doing this project virtually. We were talking about doing this project virtually, and me and Abhinay, in the meanwhile, I know in a parallel conversation, were always exchanging these clips, which were everyday object, but it was cake, and everything. How everything was hyper real, hyper simulated. How flavors were sort of hyper real in the real world sense of terms. So thinking about what a simulation is and what is reality and what is virtual versus what is digital. And it was all about the technology is remaining the same, but it was all about how we engage with these tools. It wasn't like the technology was advancing, it was just how we started using them, which was what happened at the beginning of the pandemic. I mean, we always had these video calls, we always had screens, very integrated microphones available to us, but how we started to view them, how we started to engage with them changed significantly during that time. I mean, a lot of us started working predominantly online once this medium was, you know, once we were, cornered to use this medium. And the idea of in real time came about, where, the idea of listening to our environment as a crucial means of having signals, and how we engage with the environment so subconsciously on a just by a sense of listening, and not just other mediums. So we tried to sort of use sounds to shift these visuals that were coming on screen. You can play around with this virtual installation. So we could do a little activity, and we could also speak about the virtual, where where the past, the present, and the future coexist, where we are talking about these ambiences in this simulated ambience, where we are nowhere in particular but everywhere at this one crucial point. And the idea of space, the site, time, and sort of embedded subjectivity sort of kept on emerging on the surface. And the work sort of nudges the listeners to basically realize that the virtual is not just basically on the screen in front of you, but it's happening. It's very much embedded within your phones, within the screensavers you're using, within the flavors that you're ingesting. So, as a sort of a listening exercise, I'm going to like ask everybody to switch their cameras off, and I'll share my screen. And this is what basically you need to do is switch on your microphones. Hang on. So within your Zoom settings, in the audio settings, you have to set this to a faint background sound, like allow your background sound if everybody can do that, and sort of switch on their microphones simultaneously, and like we could perhaps like try and listen to our ambience for a bit as we go along. Feel free to leave it switched on all through the the the, the like the the workshop. All right. If your home is like mine, you hear the humming sound of a printer, the children playing about, the low throbbing of traffic from nearby highways, and the clatter of plastic followed by the muffled impact of toys landing on the floor. The slight trick in this question is that by asking you what you were hearing, your brain is prompted to take control of the sensory experience and made you think rather than just hear. That, in effect, is what happens when an event jumps out of the background enough to be perceived consciously rather than just being part of your auditory surroundings. The difference between the sense of hearing and the skill of listening is attention. Hearing is vastly underrated sense. We tend to think of the world as a place that we see, interacting with things and people based on how they look. Studies have shown that conscious thought takes place at about the same rate as visual recognition, requiring a significant fraction of a second per event. But hearing is a quantitatively faster sense. While it might take you a full second to notice something out of the corner of your eye, turn your attention towards it, recognize it, and respond to it. The same reaction to a new sudden sound appears at least 10 times as fast. This basically happens because hearing has evolved as our alarm system. It operates out of the line of sight and works even while you are asleep. And because there is no place in the universe that is totally silent, your auditory system has evolved a complex and automatic volume control, fine-tuned by development and experience to keep most sounds out of your cognitive radar, unless they might be of use as a signal that something dangerous or wonderful is somewhere within the kilometer or so that your ears can detect. Hearing is short and easy. You and every other vertebrae that hasn't suffered some genetic, developmental, or environmental accident have been doing it for hundreds of millions of years. It's your lifeline, your alarm system, your way to escape danger and pass on your genes. But listening, really listening, is hard when potential distractions are leaping into your ears every 50,000th of a second, and pathways in your brain are just waiting to interrupt your focus to warn you of any, and paying attention to non-visual parts of your world feeds into everything from your intellectual sharpness to your dance skills. Luckily, we can train our listening just as with any other skill. Listening to new music when jogging rather than familiar tunes is known to develop your brain and also assimilate information much better. So, we're going to basically speak about the this concept of neurophysics, which is basically asking questions in neurology that physics has been asking for generations. So, like some recent insights into the recent field of neurophysics is what is space? Space is something you can feel, you can see, it's there, and You can see the walls, but I can't see the space in between, basically. But it's there. It's a very real concept, but our perception sort of mineralizes it. So, an even more complex question of time is something that we are going to address during this lecture. So, time is something that scientists, even to this day, time, reality are two factors that even today scientists haven't been able to quantify in a more quantify or divine or define rather in a proper way. So we ask this from a point of like, how come like when while someone is sitting in a remote corner on the earth with nothing but paper and a pencil, we can figure out how the universe began, something we've never experienced nor will experience, like something like black hole, which no one has experienced, but we can understand them. How does this weird imagination that we have make sense of things that don't seem to exist, but do they exist? Is the ability to create sense of things that don't really exist unique to humans, or do animals have that as well? We kind of know of birds that travel from the North Pole to the South Pole without a GPS, and that can travel, navigate perfectly well, and even catch fish from the ocean on the way. So the birds and the fish live in completely different environments, yet they share a perfect idea of space and time with amazing precision. If that precision was off, like even by the smallest amount, the bird will never catch the fish, and so on, and life on this planet will come to an end. Something fundamental is going on when you perceive space and time, and it's not just your imagination, it's kind of something like universal imagination. And our brain has the faculty to do that. The brain, basically a lump of tissue that's really small, yet more than a third of diseases are neurological in nature. So these questions are really important, where the brain has billions of neurons, and the special thing about the brain is there are trillions of synapses or connections, unlike the human body. And these synapses generate amazingly complex circuits, and scientists have developed these circuits over the decade. I'm going to share a circuit diagram basically of the visual of vision basically. And basically when can you see a circuit diagram, guys?
Yes, yes.
Okay. So this is basically a circuit diagram of the visual part of the brain. The auditory circuit doesn't differ much from this. So the bottom of the circuit is a region, is the eye, and the region on top is the hippocampus. So the hippocampus is far removed from all the sensing hardnesses, all your sensory faculties, and it's a very fragile region located in your brain. And unfortunately, that's the part gets inflicted with a whole range of neurological disorders, for many of which there are obviously no cures at the moment. The hippocampus also creates perception of space, and so it's universal in all species. The way it creates the perception of space is it does it by basically creating its own rhythms. And those rhythms are generated by the brain. From those rhythms, it creates these and motifs and to wait a second, motifs and one second. I had a recording over here. And okay, well, basically, not only do these motifs get switched on when you're acting in space and time, but they're also switched on when you're asleep, when you're walking, and going about your daily activities. And this combination of rhythms across many parts of your brain generates lasting memories. Now, if you want to ask a question about like how it works, uh, this is exactly what like an experiment by Professor Dr. like Mayank Mehta, who works in the departments of physics and astronomy and neurology, has conducted. So he basically he was listening to the activity of just like one single neuron in a rat as it navigated a small little maze. and he wanted to basically trigger happy memories. So every time the rat completed a task, it gave the rat a bit of chocolate, and the experiment was called Chocolate Rain because he wanted to give the rats happy memories. So these little bits of chocolate appeared from nowhere as the rat navigated the maze, and all the rat had to do was basically eat a bit of chocolate. And the idea is that the space information would still be there. So the path of the rat was measured visually and actively as one neuron is a cradle, as the cradle of sound wave. And so I'm just going to play a quick clip, the sound of a neuron. And this is happening in virtual reality. So basically, what the doctor did was he strapped the rat into like a tuxedo sort of harness and put them in this VR model thing where you can see where the rat is. Can you all see this?
Yes.
So he was basically conducting this experiment where the rat was navigating a virtual space, and as it could see its own shadows, like human beings can't see their own shadow in a virtual setup because obviously, like we have headsets, but that is something that you can't do with rats, so they can see their own shadow, and this gives them a certain sense of place as well. So they navigate these spaces in a very different way. So what Dr. Mayank did was he basically wanted to listen to the sound of a single neuron. So I'm just going to play that flight. So, uh, so in this experiment, he exposed this rat to this environment for half an hour, and the rat behaved as the rat would. He scratched himself. He created this music with by just in just like one specific area of his brain. And this is how every one of the 100 billion neurons in your brain sounds like, but you don't hear it. So, I mean, what's so special about about that place? And if you listen to another neuron, it will be active in another part of the brain. Just like different neurons are active in different parts of the brains. You only listen to like 100 neurons out of the million parts of the brain, but you can't tell where the rat is with that much accuracy. You can read off the brain and tell where he is exactly in the maze. In fact, you can do that even while the rat is asleep. You can tell that he is dreaming of doing something, what he is doing in his dream. There are fascinating possibilities with this technology, but the question remains about, like, what is space and how did the brain create that perception with such amazing precision? And to do that, uh, we need to basically need an ability to measure, to actively measure the rat's brain and in the same conditions as a human. So like a rat's nose is an inch away from the ground and we don't navigate space that way. So our olfactory sense is something that we had to rule out of this experiment. So so we so, like, how do we convince the rat to behave like us, and how do we manipulate space basically? Because in science, we are always manipulating space to simulate specific condition. So that's how the idea of like VR for rats came about. And uh, in basic, uh, one second. So the virtual reality map, like basically looked like this as he was navigating space. The virtual reality map is on the right hand side. So the virtual reality map showed that there's no spatial selectivity left. Basically, the rat was just navigating space, and it was hang on.
Sorry.
All right. So, the same experiment, when conducted in the real world on the same neuron, on the same day, basically gave us a set of visual clues and behaviors. And this was mapped just like the virtual one was. And it resulted in a more detailed map, revealing that in the VR section, in the VR version of the experiment, half the hippocampus has shut down, and basically it behaved as if someone like had drugged the brain to shut it down. And that's what like can I have a second, please? Okay. So basically, the virtual reality map showed us that there was no spatial selectivity left within the rat. And the same experiment, when conducted in the real world on the same specific neuron with the same set of visual clues, behavior, and sonic impulses, resulted in a far more detailed and like map where it showed that the half of the hippocampus was shut down during exposure to VR side of the experiments, and the brain sort of behaved that it was a drug that could shut it down. And the audio of the sound of the neuron in the real world was different. Can you hear that?
Mm.
So, so what was different was you can listen to the activity of the neuron, but like what the difference is, it is in time. It's that this is the same. It had the same VR cues, but the new music of the neuron, the feedback that you receive, is still the same. And what you notice is that the brain itself is generating a rhythm, and it's generating a little motif that are several seconds longer than the ones in the VR section of the experiment. So the speed of it like differs at a thousandth of a second, and your brain stitches together these sonic sort of brief seconds of time to create abstract ideas of space, and it relays it to your cortex. And time, and when those brief segments are all registered within each other, and things work beautifully in the real world, and in VR they get busted. So like they are now basically understanding that even a rat can differentiate it between like what is virtual and what is real. So they are developing now like the next version of VR uh, where they can activate these virtual spaces more than in a VR setup, basically. And um, there are also like several diseases where people are not being able to tell what is real or not. And the next, generation of VR is where they think the answer lies, where they can stimulate the brain and like different sections of the brain to sort of, give them the illusion that they can get over this sort of different fears. Like some people have fears of height, and they're using these VR headsets for people to get over these fears by uh, like trainings like desensitization, basically. So it's kind of funny also. Like a lot of people complain of like motion sickness when they're wearing these VR headsets, and it's the result of the brain. Basically, motion sickness is the result of the brain receiving two conflicting signals. Well, your eyes are telling you that you're moving, but well, while your eyes can tell you that they're stationary, and your inner ear, which is your vestibular system, is kind of the system that tells you whether you're in an accelerated motion or stationary. So there's like a sort of an overlap, and your system is just confused, and it's giving conflicting bits of information. So the brain cannot reconcile these two contradicting messages, and the result is motion sickness. So we kind of feel this kind of motion sickness in VR, but that's when you are not moving at all. So your vestibular, it's, you might think that cyber sickness is the same as what VR, as the motion sickness, as motion sickness, but it's basically like your vestibular system, which is like this coiled structure within your ear that is not, it's not activated in VR because it knows that you're standing still, but it's your eyes giving the contradicting information this time. So like, because cyber sickness is thought to be a result of this illusion basically, which was quite interesting. It can generate like varied affects in people, and a lot of people complain that, wearing a VR headset gives them a headache or gives them the illusion of like being sick. So another, we're going to talk about memories now, and the the another concept that the human brains built with this concept, with this perception, is memories, basically language and sound. It's a crucial fabric and of how they're built. So when we have conscious thoughts, we can often hear a voice inside our head. Now, new research is revealing why, and why do we include sounds and words in our thoughts? Like, how, when you realize that when you're reading, you can actually have this sort of illusion that you're hearing yourself speak in your head. And we're going to speak about how this illusion is formed in your head. So we are going to ask a simple question, which is like, basically, what is language made of? Language consists of words and rules of combination, but from the point of view of physics, it exists in two different physical spaces, which is outside your brain and inside it. So now I just thinking about language via physics and not via like what we are familiar with. So when it lives outside of our brain, it consists of mechanical acoustic waves of compressed and rarefied molecules of air, which is basically a fancier version for sound. When it exists inside our brain, it consists of electric waves that are a channel of communication for neurons. Waves in either case, basically, and this is considered stuff of which language is physically made. So there's an obvious connection between the sound waves and the brains, just as we saw with the experiment with the rat. And the sound is what allows the contents of the brains, as expressed in word, to enter another brain. So that forms like a basis for communication and, of course, like, a linguistic exchange. There are other, there are of course like other ways for brains to exchange this linguistic information, which is through your eyes, which is lip reading, so through via sign language, and through also like different tactile systems such as Braille or the Tadoma method, which is basically uh, used by people who are deaf-blind. And it's basically like placing your hand over someone's jaw and throat and sort of tracking those movements. So that's also another tactile approach of communication. So sound basically enters through our ears and it travels across the tympanic membrane. And let me show you actually quickly. If you're around the screen, yeah. Sound enters through our ears and it travels across the tympanic membrane. The three tiniest bones that exist within our ears, basically known as the ossicles, which enable hearing, and the organ of corti, which is in the cochlea, which is a snail-shaped organ that plays a which plays a pivotal role in the process of balance of hearing, and also like acceleration. Basically, it's like an accelerometer inside your head, so it kind of is also responsible for the feeling of nausea. So it's funny how like everything is related to your ears, and like how a lot of your physical faculties are. So like these are complex system and they translate acoustic signals into mechanical vibrations, and your cilia, which is basically like hair-like structures, they convert these mechanical vibrations into electrical impulses, and they decompose these complex sound waves into basic frequencies and characterize them. And these frequencies are mapped basically to different sections of your brain via the auditory cortex. So basically, like physical sound waves are being translated into the electric waves and being communicated to your brain. So, so there was this amazing work by a Nobel Prize winning electrophysiologist. Electrophysiologists are basically people who study electrical stimulus on the human body. Lord Edgar Adrian was the one who has stated that, no physical signal is ever completely lost when it reaches the brain. So what we've most recently discovered, like based on his theories, is quite surprising, and that apparently like electric waves preserve the shape of the corresponding sound waves in non-acoustic areas of the brain. And these specific areas are basically responsible for speech production. And also like they also light up like different areas of the brain which are activated by light, by vision rather, not light, sorry. So it this simple fact basically immediately raised like questions. Following crucial question is like, what happens to the electric waves in our brain when we generate a linguistic expression without emitting any sound? So basically, when you're thinking about talking, so we go back to basically asking like 16 patients. This is an experiment that Lord Edgar Adrian conducted. Was basically he asked patients to read linguistic expressions aloud. So basically, they were some of them were just uttering full-on sentences, and some of them were just uttering isolated words. And he compared the shape of these acoustic shapes with the shape of an electric wave in the Broca's area, which is an area in the human brain. And they observed the correlation between them. And this observing this correlation was very crucial. And as he asked the patient to read the linguistic expressions again, and this time without emitting any sound, they read them just in their mind. So by analogy, he compared the shape of the acoustic wave with the shape of the electric wave, basically. And he was basically trying to map if the signal carried by these waves conveyed alphabetical letters that we use to represent words, but definitely not in an acoustic format, but in a visual format. So he found that the shape of these waves recorded in a non acoustic area of the brain when the linguistic expressions were being read silently preserved the same structure as those with the mechanical waves, sound waves emitted in the air when you enunciate words. So these two families of waves of language live physically and are closely related, closely in the fact that they do overlap basically independently the absence and presence of sound, which was a really interesting, faculty. So the discovery that these two basically independent family of waves, of which language is physically made strictly to correlate with each other, even in non acoustic areas, and whether or not in linguistic structures they're uttered or not, they remain within the mind of an individual and indicate that sounds play a much more central role in language processing than we previously thought. So, among the questions this discovery raised is what kind of electrical activity is elaborated in a language network by persons who've been able to hear any sound from birth? And can we exploit electrocortical information to access the linguistic thinking of aphasic patients whose articulatory apparatus alone has been damaged? Um, Aphasic is basically the inability to understand or produce speech as a result of brain damage or any other nervous condition. So we consider, like they were trying to consider if stuttering as a form of coordination between different sound representations and networks in the brain. And they were hoping to find a cure from it using this very findings, and how these uh, basically basically the very fact that the majority of a communication takes place via waves may not be a causal fact after all, because waves constitute the purest system of communication, and since they transfer information from one entity to another without changing the structure or the composition of these two entities, and they travel through us and leave us intact, but they allow us to interpret the message borne by their momentary vibrations, and provide that provided that we have the key to decode it. Basically, it's not all accidental in terms of information is derived from the Latin word forma, which is shape, and to inform is to share a shape. So basically, that's how like the whole brain system works in coordination with itself to give us the perception of space, memories, and time. So yeah, that's all, guys. I'm having a bit of difficulty, like keeping my voice going. Uh,
That was intense.
That was
it
amazing.
was it
Take
was
it to that.
non-stop, wasn't it? I should have broken it down. Like while I was going through it, I was like, I should have just.
No, but about
No,
what you said of memory was something I think that at least I always wonder about and how that comes in.
There were a lot more like interesting things that I came about, but I honestly like thought like I would run out of time, and I could have had the chance to include it. Especially like this idea of like cyber sickness was something that I was reading, and it was really interesting how the same two faculties can basically just
Oh,
switch
cyber
places.
sickness.
Yeah, it's that feeling, when you put on a virtual headset and you get this feeling of either like you're feeling dizzy or nauseous. And they
mm,
have a word for it now because it seems to be becoming something that's more and more apparent in this day and age. And it's specifically because in normal, like I was saying, right, like in normal motion sickness, it's your eyes giving you the perception that you're steady, but your body knows that like it's in under movement. But that's kind of switched around because while you have a VR headset on, your body knows that it's steady, but your eyes are sending like the opposing, contradicting signals that it's undergoing some sort of movement. And it's kind of interesting, like how the next wave of like VR is coming on, and
mm.
we're coming up with like different experiences, especially like experiences like the metaverse that's happening right now. And I don't know, for me, it just seems like a more overwhelming version of Zoom. But I think it's a new way of socializing and engaging for a lot of people, where you can basically like buy assets, buy like physical everyday objects like clothes and carry them on to like other cross platforms as well. And it's just interesting how it's going to change how we navigate these spaces. But I don't know. I think we're at still a very nascent stage. It's like being at the cusp of like, the invention of the internet and trying to predict what sort of form it'll take. It's a bit too early, but it's nice. It's nice. What a time to be alive, where we have this option basically. Yeah.
Also, a time when we can comprehend this change.
Yeah, yeah. I mean, like, when we all started like 2 years ago with this whole virtual meetups and everything. I mean, it was already existent, and we never thought that we'd be so reliant on it as a medium, to not on a daily basis, but it's just so easily integrated into our daily lives now. That, guys, have any questions? I can answer anything. Did I go too fast? I could go back, elaborate on anything if you want.
Um, I was actually like viewing your work on future landing while you were talking, and it was so nice.
Was it
Um,
moving?
yeah, it was. Yeah, yeah. I was wondering if you had any reading references that you might want to share. So,
So like, would you like? So like, I usually read like research papers. If that's up your alley, I'm more than happy to send you stuff.
oh,
Uh, I can definitely like drop a few references. Hang on, there's quite a few interesting ones that I've been reading right now. Let me just send you some. This is the book actually. I'm just gonna drop these. This was interesting. I think it might have like stuff marked up by me, so excuse that bit. Like I have a habit to go crazy with the highlighter sometimes. Um, where did it go? This was also interesting read. If you, I mean, it's all going to be sound related. If that's like
mm-hmm.
right. Mm, this was also interesting. Yeah, this was also nice. Okay, I can drop a lot of these. Tell me when to stop. Okay.
Yeah, thank you so much. I'll try to go through these.
Yeah, I mean, feel free to reach out if you want to share some reading. Like, I'm more than happy to
Yeah.
like send like work across. Mm. This was interesting, but I don't have the full access to the full book yet. But I mean, if you can, if you have like a library account, maybe you can get the whole book. And this is interesting as well. Okay, I'm gonna stop. Uh, there's a lot. Um,
Does anyone have any questions for Farah?
I'm more amazed by like, so I only have questions.
go for it.
Like, I mean, how does a mouse belong in a VR space? Like, that's just like very mind blowing for me.
Well,
And in
well,
connection with that, I'm interested in the shadow and how that comes in.
exactly, right? Because like, like it's like watching your own image, but this is basically reduced like with information is just a shadow. Like when you can watch your own shadow, you can still watch like coordination happening. So that's like more something that's offering you that sense of immediacy. Like a lot of video games and simulations are also incorporating this idea of what happens to a person when they look down. You can still see your clothes, your attire, and it's something about like grounding people within those environments, because like a huge aspect of uh, technology right now is immersivity, and immersivity also has a huge factor to play with individualization, because every experience of these environments is unique. So like when you're wearing a headset, everybody's not listening to the same soundscape. It's changing as you're moving along. You're basically a little more in control than you were with like older video games. So these sort of simulations, they try to trick your brain into thinking that you are actually present into the environment. And, I think maybe they started incorporating this idea of, including your shadow within your game to make like self-presence and subjectivity be so immediate. It's kind of ridiculous how, all of these illusions that, that trick you into believing you're in these weird simulations.
There was like this Justin Bieber concert that happened on the metaverse recently. So that
Are
was
you
also
are
super
you
interesting.
are you an active member of the metaverse yet?
No. I just like came across an article that sort of put that out. So that was kind of absurd and also like kind of new. So yeah,
Just 2 days ago, there was this couple in Tamil Nadu who got married and
yeah.
basically, what do you call it? Had their reception in the metaverse.
Mhm.
Ayoka. But yeah, I mean, they're trying to replace the lived experience by generating these varied affects in a simulation, which is weirdly interesting and also disturbing. Also disturbing, like when we talk about things like what is free will, what is control, and I think there's like a downward spiral happening with like we have zero control about like forget your data. I mean, also your likeness is also something that people are giving up, you know, control over when we choose to be a part of these simulations. And, Meta Facebook and all those platforms are just, I don't know how I feel about it right now.
I had a question about the sound that you played, about the neuron when it reacts. How did he capture that sound?
So that's interesting because that's something I was also trying to get into. And basically, they have these really tiny electrodes and they isolate. So, like, they're not supposed to harm the animal or the neuron. So, they're supposed to get these readings without damaging them. So, they attach these really tiny, minuscule electrodes to it and they just capture the sound of just that. It's an electric, basically, impulse. So, what you're measuring, which was the same, like, what was happening during memories, they were just measuring signals coming out, so electricity that's coming out from your brain, and that was the sound of the electricity. So it's like a positive affirmation that's coming out, like, okay, it's in a familiar space now. And it's amazing how just via this sound and like from like the kind of waveform it generates, they can determine what the rat is dreaming about, like, what he's thinking about, which is kind of ridiculous, like the kind of information you can extract out of a blip. Like, yeah.
Anyone else? Cool. Thank you, Farah. This was super fascinating. I'm sure everyone will love to listen to this. Even like I'll have to revisit this to understand a lot more, like a lot better. But thank you.
Thank
Thank
you.
And
you.
thank you
Thank you, Farah.
everyone for
Thank you, Farah.
coming.
Thank you. Speak soon and take care.